Hi everyone. In this section we can discuss about the general equations required for the band break, which is used for simple band break and differential band break. These are the general equations that we used for a simple band break. The average pressure between the band and brake shift. The equation is equal P is equal to F1 plus F2 divided by D into V. So that is in our data page number 268. Page number 268, equation number 13.18k. You can read the values from your data book. P is equal to F1 plus F2 divided by dB. In our data book they are using capital B, but actually that is a small letter b. B is the bandwidth. Then next one, pressure at high tension end of the band, that is denoted as P1. High tension band, it is denoted as P1, that is equal to 2F1 divided by dB. That is in our data book page number 269, and equation number 13.18L. P1 is equal to 2F1 divided by dB. Similarly, the third point, that is the pressure at low tension end. We can denote it as P2, that is equal to dF2 divided by dB. And one more thing, here the major difference is F1 and F2, that is the tension at tight side and tension at slack side. And next equation is the band thickness, H is equal to 0.005 D. That is in our data book page number 269, and equation number 13.18 N. That equation is already given, H is equal to 0.005 D. Then next value for next equation, the bandwidth, B is equal to F1 divided by H into sigma D. Here in our data book that equation is on page number 269, equation number 13.18O. Here sigma D is the design stress of band, and all other parameters we already know, that is H is the band thickness, and F1 we already know that is tight side tension. Then another equations, general equations, the F1 value is equal to Ft into e to the power of mu theta, or e to the power of f theta divided by e to the power of f theta minus 1. This equation is given in our data book page number 267, equation number 13.18C. Similarly F2, that is the low tension side, F2 is equal to Ft into 1 divided by e raised to mu theta, or e raised to f theta minus 1. That is in equation number page number 13.18D and page number 267. Then last equation, that is the tight side by slack side, F1 by F2 is equal to e raised to mu theta, or e raised to f theta. That is equation number 13.18A in the page number 267. So these are the general equations needed for band break. So you have to familiarize these equations first of all, then we can go for a problem. Listen, I can read the problem. A simple band break is shown in figure. The diameter of the drum is 900 mm and the band thickness is 5 mm. The coefficient of friction is 0.25 and arc of contact is 270 degree. The brake drum is attached to a hoisting drum that sustains a load of 9 kN. The operating force has a moment arm of 1.5 meter and the band is attached 200 mm from the pivot point. Determine force required to just support the load. Next one, force when the direction of rotation is reversed. Then third one, bandwidth. Take 50 megapascal, that is sigma is equal to 50 megapascal. Now just write this question and draw this figure. This is the free body diagram. Here the distance they are given From the pivot center to the force acting point is 1500. Then pivot center to the band attached is 200. Then the arc of contact, the angle of contact is given, that is equal to 270 degree, and the direction is also given, that is in the clockwise direction. Now we can write the given data. What are the given data is given? Data is given D is equal to 600 mm and H, that is the thickness, H is equal to 5 mm. Coefficient of friction we can write it as F or mu. Mu is equal to 0.25. Then Ft is given, that is equal to, in here the band break, it is F1 minus F2, that is the tight side tension minus slack side tension, that is equal to 9 kilonewton. Then sigma D is given 50 megapascal. We have to find F minimum, F and B, the width. So we can just compare this figure with our data book. From our data book, page number 270, we have a simple band break, and there is a similarity with our data book with this figure, that is figure number E. It is almost similar, there is no changes, and here it is clockwise direction. So we can take the equation for clockwise direction from our data book, page number 270, figure number E, and equation number 13.19C. Now we can go for the solution. We can just compare with our data book. The values are given. What is the value? A is equal to 1500 and B is equal to 200. Angle of theta, theta is equal to 270 degree, or we can convert it into pi by into radian, that is equal to 4.712 radian. Now for clockwise direction. For clockwise direction, from the page number 270, equation number 13.19C, F is equal to B F2 divided by A, or that is equal to Ft into B divided by A into 1 divided by E raised to mu theta minus 1. That is the equation in our data book. The equation is similar here. Now we have to find all the datas, all the parameters here. What is the value of E raised to mu theta? Mu and theta are given. So we can find E raised to mu theta value, that is 3.28. Then Ft is already given in the question, that is equal to F1 minus F2 is equal to 9 kilonewton. And we know that F1 by F2 is equal to E raised to mu theta. That is given in our data book, page number 267, equation number 13.18a. F1 by F2 is equal to E raised to mu theta. Now we can use this equation, that is E raised to mu theta is equal to 3.28 or F1 in terms of F2. So if we get the value of F1 in terms of F2, we can substitute that F1 value in the previous equation, that is Ft is equal to F1 minus F2 in this equation. If we substitute this value, we will get F2 and F1. Then if we get F2 and F1, the value will become F2 is equal to 4003.56 Newton and F1 value is equal to 13,003.56 Newton. Now we can substitute all these values in the first equation, that is this equation. If we substitute the value of Ft, that is 9000 Newton here, and B the value 200, then A value is 1500, and we calculate the value of E raised to mu theta as 3.28. If we substitute, we will get F minimum is equal to 533.81 Newton. The value of F2 and F1 we need for the further steps. Then second one. What is the value of second question? They are asking about the force when the direction of rotation is reversed. What will happen? For the counterclockwise direction, we need to take the value of F. How we can find that equation? That equation is in our data book, page number 270. Equation number 13.19D. What is that equation? F is equal to Ft into B divided by A into E raised to F theta divided by E raised to F theta minus 1. In our data book, it is denoted as E raised to mu theta. And if we substitute these values in this equation, we will get F is equal to 1733.81 Newton. So this is the second condition. Then next they are asking about the bandwidth. How we can find the bandwidth? Bandwidth we can find using the equation B is equal to F1 divided by H into sigma D. That is given in our data book page number 269, equation number 13.180. What is that equation? B is equal to F1 divided by H into sigma D. So sigma D is here, sigma D is a given data, and F1 we already calculated in the first step itself. The value of H is given, then we can find the bandwidth. This is the bandwidth. So this is about simple band break problem. Okay, thank you.